Hi, this is Kevin Trainer, and welcome to my tutorial video on the classes motorcycle and motorcycle test. We're doing this as part of our work in Chapter 8 in the Reggie's and Step Java textbook. And we've kind of deviated from the text a bit in chapter 8. First of all, we broke it up into 2 weeks of work, part 1 and part 2. This is part of part 2. And in part 2, in terms of the tutorial demo that I've already done previous to this, I showed you how to use the JUnit testing framework. And in this tutorial, I'm gonna teach you two more skills. The first one is going to be how to design a class with uh, many constructors. Okay, we started out when we learned how to make a custom class with just the no argument constructor. And then we moved on and we created a constructor that had an argument for each of the instance variables in the class. And that's the classic overloaded constructor. Um, what we're going to learn how to do is we're going to learn to have shades of overloaded constructor. So we're going to learn how to do that, and we're going to learn how to coordinate amongst those constructors. Okay. And the other thing we're going to do is we're going to take our testing with the JUnit and press a little bit harder and use an approach that grew out of JUnit testing called test-driven development. And just to give you a peek ahead, what we've been doing so far in terms of testing our classes is, for the most part, we write the class itself, the production class, and then we write the test class. When we get towards the end, we do a little bit of alternating between the two. So what we're going to do is we're going to change around some of that, and wherever possible, we're going to write the test code before the production code. And it's going to turn out that that's favorable. Okay? It's a little counterintuitive, but it's favorable. So we're going to be taking a look at that too. The class that we're going to be building is another one of these transportation-oriented classes called motorcycle. And then I've given you an assignment as part of your homework and stuff to create one called boat. And it's not accidental that we're creating all these transportation related vehicle classes because in a couple of weeks we're going to be dealing with inheritance and interfaces. And we're going to be thinking about things like superclasses and subclasses. And when we do that, we're going to be really happy that we have some classes that we know well that already have a lot in common. Okay, so here's the motorcycle class. So it's going to go into the net.legend.students.transportation package. So it's going to go in there with car. And I'm going to just ask for a new class. And I'm going to call it motorcycle. Okay. It's not going to get a main because it's an object-oriented class. Okay. And I also have down in my test source code folder, I also have already created a package to correspond with that package, net.legend.students.transportation. And right now it's holding car test, and I want to create a motorcycle test. So I'm going to right click, new JUnit test case. I've already said this is a bit of a misnomer because it's really a JUnit test class. The individual little tests we put into the into each of the methods, those are really test cases, but they called it whatever they did. So this is going to be called motorcycle test, because that's how we usually do it. For right now, we're not going to do the setup before class. I thought about having you do that, but I don't think we want to be there quite this week. Okay? And finish. Okay? So, let's think about the first thing that we need. Okay? So, let's think we need instance variables. Okay? If we're consulting with our famous recipe for creating a new custom class. Does it have a testing equivalent? Do we test those directly? No, we really don't. So if we say we're going to test first, do we really mean that we're going to start testing before we create our instance variables? And the answer is no. It's not practical. All right. So let's create our instance variables. Okay, so I like my little comment. So always private, okay? And I'm going to say that the fields that the motorcycle class has are very, very similar to ones that the car class had. And that's going to become pretty important in a couple of weeks. But right now, it's just an interesting coincidence, okay? So I'm thinking we need make, model, year, color, vehicle identification number. Those are all the same. And then I want engine displacement in cubic centimeters, cc's, because I want to use that to figure out how much we're going to charge them for their annual registration fee. The bigger the bike, the more I want to charge them. Call me greedy. Okay? So let's look at this. Make, string make, right? Private string model, private string, not a string, private int year, private string color. Okay. Engine displacement in cc's. Sounds like a whole number to me. Sounds like an int. Private int engine displacement in ccs. How's that? Now, only the first letter. Capital C, small c, yes, in cc's. Okay? And then vehicle identification number, private string. I do want to call it the same thing I called it in car. So I'm just going to take a peek in car. Let's open up car. What did I call it there? Vehicle ID number. Well, I'm just going to copy that code. Okay? So I have that. Because I want them to have a kind of a parallelism. Okay? And that gets rid of the problem where I had capitalized the word private and that was inappropriate. Okay, so I have my fields. Okay, well, the next thing that I create are typically my getters and setters. Okay, so let's look at this. Are there any special consideration for these fields? Like, does a setter, for instance, need to be private because we have interrelated fields that should only be set in our constructor code? No, probably not. Okay, so we probably just want to generate the getters and setters, public ones, for all the fields. So let's create getters and setters. All right, let's do that. So source, generate getters and setters. And it wants to, it has them all here. Yeah, let's just say all. Correct. Collect, generate getters and setters for that. It wants to put it after vehicle number. That's the last thing I described. That's good. Fields and getter setter pairs, public. Yeah, it looks good. Okay. The only thing I don't like, well, really two things that I don't like. I don't like my comment being in the wrong place now. So let's get the comment in the right place. Okay, I did that with a cut paste. And the other thing is that I like to see blank lines in between those getters and setters. And if I do a format, if I come over here and say, right click in the editor, say source format, it's going to spread those getters and setters out so they look a little better. Okay, so I'm liking that. Maybe a nice time to save. Okay, so now let's just think about that. Do I have something that I'm ready to test yet? Well, it turns out no. And why? Well, because as you saw in the testing that we've done so far, we typically don't test getters and setters directly because most getters and setters are what we call too small to fail. Okay, they've got their generated code. Okay, so they're pretty reliable. And the other thing is that we can implicitly test getters and setters, particularly when we test the overloaded constructor, the one in which we pass in initial values for all the fields. Okay? So since we're not ready to test the constructor yet because we don't have a constructor, then I think this is a time when we still just want to build the class. I know we said that we were going to, wherever possible, do test code before production code, but we're not ready yet. Okay? All right, so we've saved that. Now what comes next? Well, if you consult your recipe, you're going to see it's constructors. Okay. Constructors is a place where we are going to go right here. Now, I'm going to cheat on constructors a bit. Okay? Constructor says, right? We say that it's always a good process. If you read my recipe, you see it's always a good practice to create an explicit no argument constructor. Well, I haven't done that yet. So I'm going to show you how things go bad when you don't do that. Okay? Well, let's do that. So let's start writing the test code first. Okay? I'm going to close car because I don't want to be cheating off of that any more than I already have. So I'm going to go to MotorcycleTest, and I have a test. Okay, I've got one test. I thought I said I didn't want the before. Let's just get rid of that. Somehow I got that. Okay. Not yet implemented. Fail. Okay. So let's let's call this something. So let's call it what we want. Test no argument constructor. Okay. It's good. Okay. And it should fail. We always want to force the fail to make sure that we're actually running this test. Because if you forget to wire this in with a proper annotation, it doesn't run and you get a false pass. Ah, that failed. Oh, that's beautiful. Beautiful failure. Okay. So let's think about this. So we want a new motorcycle. Okay. So let's say motorcycle M1 equals new, motorcycle, paren. This calls, I know that when we first thought about classes, we probably thought that what we had here was the name of the class, but as we've now learned, it's the name of a special method that just happens to be named the same thing as the class, the constructor. So this is the no argument one. So we're calling the no argument one, right? So we want to call that. And then I just want to know that I didn't get back a null. I got back a properly constructed object. So just like I did in the last of the unit tests I showed you how to do, I'm going to assert not capital N, null capital N, assert not null M1. Okay? All right. Now, ask yourself, did I code an explicit no argument constructor? No, I didn't. Okay. Let's see if this passes. Yeah, it passes just fine. Well, that's surprising. Well, something I haven't emphasized in my class is that if you don't have any constructors at all, none, if you have no explicitly coded constructors, the Java infrastructure will generate a no argument constructor for you implicitly. Okay, and why do we do that? Well, to help people who are taking baby steps. So this is a training wheel phase that we had you skip. Okay, we had you get right on the two-wheel bike and start going. Okay, now we're going to just keep. We're going to say here that that's okay. We're going to rely on the implicit no argument constructor. We're going to see how that test is going to fail as soon as we get an explicit constructor. Okay, I just wanted you to see that because you can forget and you can get into this trouble. So I'd like you to get into it with me. Okay, let's create another test. So now you're going to see me being a little more likely to clone one test into the next one because I don't like to type a lot. So I clone that, okay, and I'm going to get a problem that it doesn't like the name, okay, and what do I want to test? Well, I'm going to call this the fully overloaded constructor. This is the one to which we pass all the arguments. Fully overloaded constructor. Okay, and I just want to to emphasize again, as I know that I will have in the lecture by now, what it means to be overloaded. A method, or in this case, the constructor, is overloaded if it has the same name as another method or constructor and has a different parameter list. And it has to be different in terms of the number, the type, and the order of the parameters. Okay, so the no argument constructor has no parameters. This one's going to have a whole slew of them, so it's going to be overloaded, and it's fully overloaded because it's got all of the parameters. Okay, so let's look at this test. So this is a good time for us to construct the expected fields. So let's say string expected make equals Indian. Indian was a highly respected make of bike. I don't know that they make them anymore. And perhaps they appropriated the name of the native peoples of the United States, and we might not consider that appropriate anymore, but it was such a good bike that I think they've done the native peoples some kind of honor. So I I think it's okay to include that. String expected model equals, and I don't know what to call it, so let's call it the respect, because we want a lot of respect in here. We just claim we had respect. So we have an Indian respect. The year is going to be an int, so int expected year equals, and let's say 1965. Okay. Color, string expected color equals, most people like a red bike, so we're going to say red. Engine displacement, so string expected engine displacement equals, I don't know how big they were. I bet there was one that was at least 700, probably bigger. Okay. That's not a string, is it? Nope, it's an int. All right. And now we want to say vehicle identification number. So let's say string expected vehicle ID number equals, let's call it X 1 2 3 4 5 6 7, something like that. Okay. So those are the variables that we're going to use to pass into this fully overloaded constructor. Okay, let's look at this. Okay, so let's say so we need a motorcycle. We need to type the variable. Call it M1 again. That's fine. That's in a different method. Equals new motorcycle. And let's look at what's possible. Control space. Well, let's see. The only one it knows about is one that's has no arguments, and this anonymous inner type is a bad idea that we're not even going to explain. Okay, so let's just say that we're going to pass in. Let's pass in a bunch of. It's very hard to get a carriage return on these things. One of the things I like to do a lot of times is just put each of these parameters on its own line. So expected make, comma, and then come right back here and put it on its own line. Expected model, comma, expected year, comma, expected color, comma, expected E for engine, engine dis, okay, expected V for vehicle identification number. That's fine. That's all that we're passing in. Okay, and here, oh, say, I had that. I had the rest of that code, and it was just hiding down there. Okay, so what's interesting here is it says, you know, Kevin, you've written the test code before you've written the production code, and if you look over in motorcycle, it doesn't have a it doesn't have a constructor at all. Never mind a constructor that's fully overloaded like this. And I say, that's okay. Let's just hover over this, okay, and take the quick fix, create the constructor that's fully overloaded. Um, and there we go. So what we got was a fully overloaded constructor. Pretty cool, huh? I like that. Okay, so sometimes it's a little bit hard to see these things. So I'm gonna try to hang on. Yeah, try to get this thing here so you can see it. So this is good. All right, now there's something that we haven't done yet, and what we haven't done is that we have not called the setters. So sure, we've passed in the values that we want to set the instance variables, but they're not set. Let's do that wrong and see that error all by itself. Okay? A common mistake is to leave your fully overloaded constructor just like this. Looks good, right? Okay, so let's go back to MotorcycleTest and do the rest of it. Okay, so what's the first thing that we want? Well, motorcycle, we want that to be spelled the right way. Not motorcycle, motorcycle. All right, so now that's fixed. So if we construct one, the first thing I love to test for is that it's not null. So assert not null M1. Let's look. All right. It's complaining about my constructor again, so I forget what's wrong. Motorcycle. New motorcycle. I don't know. Maybe we need to save motorcycle and see what's wrong. Oh, okay. Yeah, we needed to save that, and now we come back here, and that's calmed down. Okay, now I just want to point out that's calmed down, but what's happened up here? We've got a broken test. And why? Oh, because we never added an explicit no argument constructor. So as soon as you add another constructor, any explicit constructor at all, this implicit no argument constructor, which some foolish people call the default constructor, goes away. Okay? Because it's training wheels. So as soon as you code one, they go, oh, they're not using training wheels anymore. So if they didn't code one, then they don't want one. Okay? So we're going to have to fix that. So what's the fix up? Create constructor motorcycle, create a no argument constructor. Okay? So let's just look at this again. Let's just click on that. Okay? And okay, public motorcycle, and I'm just going to call that a no argument constructor. Okay, does that look good? All right, very good. All right, so now if I go back to motorcycle test, it's not broken now. So let me just, as long as I'm here, I'm going to take this second test. I'm going to comment it out. And I'm going to go back and make sure that the first one works. And of course, the way you comment these things out, if you're on a Windows machine, you do it with Control/, and on Mac, like I'm on, you do it with Command/. Okay? So yeah, let's just back up and make sure that actually tests. Yeah, that runs just fine when the no argument constructor is explicit, which is the way that we wanted to do it. So the reason we had you doing that is that as soon as you create another constructor, you're going to need an explicit one anyway. We thought it was a good practice. Okay, so I'm going to toggle this comment off again. And I don't think we've actually run this test. So let's run this test. Okay. All right. So it's come back, it's not null. Now, is it populated? Okay. Well, I happen to know that it's not because we never called the setters, right? But let's just look. So we want to make an assert regarding the value of all of the fields in this M1 object. So how could we do that? Well, we could say assert equals, and then we can pass expected make and compare that to M1 get make. That's the actual. Expected comma actual. Okay, and this is going to blow sky high because we never called the setter. Okay. Kaboom! Didn't work. So let's look down here. Expected Indian but was null. Oh, we never set it. We passed it in just fine, but the constructor never set it. How can we fix that? Well, we go to the motorcycle class and we remember to call the setters. Okay, let's just do it. So we can say set make, and you know what? It put in expected make. Isn't that nice? And then we can say set model, and it put in expected model. It's pretty smart. Okay. And we can say set year, and we can put in expected year. Oh, it would have put that in for us. Okay. What's next? Color. Set color. And it put the code in there just like we want. And then we've got engine displacement. Set E for engine. Does that. And then I like what it did there. And then let's do the last one. Set V for vehicle ID number. Okay. Now what we've done here is what's really considered the best practice in the field, okay? There are people who in their constructors will actually touch the instance variables directly, okay? Not a good practice, okay? We have the setters for a reason, okay? It makes our code more maintainable long term, okay? So call the setters, okay? So we called the setters. We called all of them. So let's go back to MotorcycleTest and give this a run, and it passes. So now we need to make a similar assertion for each of the values that we passed. So we want to say assert equals expected model, and we want to say M1 get model, Okay, M1 get model, paren. That should work. Now, some people believe that that we should have done this in the following way. Some people believe if we're really doing test-driven code, that we should have put test in for get make, then added the call to the setter for get make in the constructor. Now come back, add this line into the test, then go back and add into the production code. You could be there your whole life. Okay, so what I tend to do is I tend to do them all as a group. Okay, so now assert equals expected year M1 get year. All right. And I just want to point out, I think I did in the last of my demos, the assert equals method that we're calling, and we can call it because of the magic of the Java infrastructure and the things we've imported and what they say and all that kind of stuff. It's overloaded. Okay, so when we tell it to compare a string and a string, it calls the dot equals. When we tell it to compare an int and an int, we're actually calling the method that takes an int and an int. So assert equals is overloaded in the same way that the constructors in this case are. Okay, so let's just take a pause and make sure I haven't introduced any errors. Nope, still passing. So I'm up to year, color, engine displacement, and vehicle ID number. Assert equals expected color, M1 get color, and then assert equals expected E for engine displacement, and then compare that to M1 get engine displacement, and assert equals expected V for vehicle identification number, and then M1 get vehicle ID number. And we have all of them right here. Okay. Now, you'll remember a little bit earlier in the demo, I said we don't have to test the getters and the setters explicitly for two reasons. One is that they're too small to fail, which is a pretty bad excuse, I've got to say. But the other one is that we're testing them implicitly. So when we test the overloaded constructor, we have tested the getters and the setters, because the setters should all be called in the fully overloaded constructor, and the getters should all be called in the test of the fully overloaded constructor. And between the two of those, we should have tested all the getters and all the setters, not explicitly. We don't have a separate test case for them, but we can't really succeed at this test fully overloaded constructor test case unless we have tested the getters and the setters. So they're tested implicitly. Okay, now let's do a little more constructor magic. It is not uncommon for us to have a need to construct a new object in which we don't want to set all the fields, but we want to set some. Now, it's very dependent on what kind of object this is. But in terms of this kind of object, I would think, what if we were trying to take an order from a new customer for a vehicle, okay? And we could say what the make is, we could say what the model is, we could say what the year is, we could say the color, we could say the displacement, but we don't want to say the expected vehicle identification number because we don't know it yet. Let's say we're ordering it, okay, and we're only going to find out the VIN when it goes through the factory process. Perhaps it's not been manufactured yet, okay? So it's typical to have constructors, more than one overloaded constructors, and sometimes they don't. Well, typically they only make sense if they specify a different number of parameters. So let's create another test. Oh, I'm not sure I failed that test. Oh, yes, I did. I did fail it when we didn't get when we hadn't set the field. So that failed just fine. So let's take this test and clone it into the next one. Okay. And you remember, so fully overloaded constructor. And let's call the last one the no VIN overloaded constructor. Okay, no vehicle identification number. Okay, so how are we expecting that to work? Well, our vehicle identification number is not going to be passed in, but we're expecting it to come back as null. Okay? Because if we're not going to initialize it in the constructor, then we're going to expect it to come back as its default value when you create a new object, and strings are initialized to null. Okay? So let's call with this, but of course there's no vehicle ID number, okay, because this one doesn't take one. All right. Now we don't have this constructor yet. We don't have one that takes all these things. So we're going to get the error that we don't have a constructor with this, and we call this combination of the name of the method, or in this case the constructor, plus the types, the number, type, and order of the arguments or the parameters. We call the combination of the name and the number, type, and order of the parameters, we call that a signature. So what it is saying here is that, hey, I don't have a constructor with that signature. And I'm going to say, oh, what the heck? Let's take the quick fix and have you create one. Okay? So it created one for us. All right? That's good. We've gotten rid of that problem. Okay. Let's go back to MotorcycleTest, though, and let's see what we have. So we're expecting all these things to be true. We're expecting M1 to be not null. We're expecting to make, the model, the year, the color, the engine displacement. We're expecting them to be set the right way. And it just so happened that we set the expected vehicle ID number to what we're expecting back. If we happen to do a call to get vehicle number, we're expecting to get back a null. Okay? And it should give us the right answer there. Now, this is going to fail because of why? Well, let's watch it fail. Gotta save it. Watch it fail because we expected Indian but got null. Oh, we didn't call any of the setters. That's interesting. So let's go over to motorcycle itself and let's decide what to do. And we are going to do something different than what you think, okay? And we're going to do this because we want to make our code maintainable, okay? Our fully overloaded constructor calls all the setters. So what we could do, for instance, is we could call all the setters explicitly. We could do what we did in the fully overload one here, except that we just wouldn't call the last one, set vehicle identification number. But we don't want to do that, okay? What we want to do is we already have this code that constructs a fully populated vehicle identification number. Let's call it with what we've been called with. Plus, the one thing we don't have is we don't have anything to call with an expected vehicle identification number. Let's just pass through a null. So this is called constructor chaining. Okay? Now, would it be okay to just call the setters that are appropriate here? You'll see a lot of code like this. Okay? Now, constructor chaining is good practice because, again, we're calling any special code that might be in this constructor we want to take advantage of. There's not a lot of special code in here, but it's considered a best practice to chain from one constructor to the next. Oh, so you say, okay, here's what we want to do. We want to call that other constructor. And so you're thinking, well, maybe I want to do a new motorcycle. That's how we call constructors, right? Can't do this, right? Sorry. New motorcycle. Well, I guess we could. It doesn't want to do that, but it won't work. Okay, here's why it won't work. It won't work because there's no way to pass back a constructor reference explicitly from one to the next. It doesn't work like that because even though constructors look like methods, they don't have a return type. So it turns out that there's a special word in Java that gets used a lot. You may have seen it in some of our getters and setters so far. It's the keyword this. Okay? And why do we use the keyword this? Well, generally, the people who were the architects of Java used the keyword this to get themselves out of a lot of tight fixes. And that becomes the name of another constructor for this same class. So if you want to call another constructor for the same class, if you want to call the default, the no argument constructor, you call this. Okay, that calls the no argument constructor. If you want to call the fully loaded one, what do you do? Well, you call it with expected make. So call it with expected make. And on the next line, we're going to call with expected model. And then expected year. And what's coming next? Color. Okay. And expected engine displacement. Okay. That's fine. And that's all we're getting passed in. If you look at the list of parameters that we're getting, the last one is expected engine displacement. Okay, then we have to make a decision for what to put into vehicle identification number. And the best decision, since we don't know what it is, let's have it be a null. That's a good meaning for a null. We don't know yet. Okay. So make, model, year, color, engine displacement, null. Add argument to match string, string, int, int. So oh, sorry. Uh, yeah. So it's year, color, engine displacement. So it should be make, model, year, color, engine displacement. No. I don't know why it's remove parameter string. There'll be a slight pause here while I figure out what I've done wrong. I don't want to punish you and me. Aha, found it. I was missing a comma after I think expected year. So that was my problem there. So at least I didn't keep you looking while I was searching. But here is an approach called constructor chaining. Okay, good practice, one that I want you to follow. Okay, so let's look at the constructors that we have. Okay, we have a no argument constructor. Okay, could I chain to the fully overloaded constructor from the no argument constructor? Technically, you could do that, but nobody does it. Okay, the no argument constructor is kind of a beast all by itself. Okay, we know that we're going to get all of the instance variables, and they're all going to have that zero, false, or null value. Okay, then we typically put the actual calls to the setters in the fully overloaded constructor. Okay. In fact, I may want to put a little comment in here, fully overloaded constructor. Okay? This is the one that does all of the values. And then all the other constructors that we have, and really, the constructors that we have that we've seen so far are really for convenience. Okay? So it's a question of what are going to be our convenient use cases. We've only dreamed up one. That's where we don't want to set the vehicle identification number. That one remaining constructor, instead of calling the setters explicitly, like it could have, it's going to chain to the fully overloaded constructor. So typically the one that does all the work is the one that takes all the parameters and calls all the setters, okay? And typically the no argument one is just a no argument one. Call it the ceremonial, okay? And then all the other constructors that you have that have fewer than all of the fields being set, they chain to the fully overloaded constructor, and they simply pass appropriate values for the fields that we're not trying to initialize. Or perhaps here we passed a null, but maybe there's a default value, okay? And we could have that in this constructor. Okay, so this is constructors up to the level that we're operating right now. A little fancier. Um, it's all for convenience, and then we know how to change from one to the other. We're using the keyword this as the name of a method that we're calling. Okay, we're calling a special method, we're calling a constructor in our class, and that's why we use this. Okay? All right, good. We got a couple more things to do on motorcycle test. Okay, so we've done the overloaded constructors, so we have all of the constructors. Let's, again, why don't we test the constructor? Save everything. That seems to be working just fine. So now what we're going to do, we've learned the fancier constructor stuff. Now we're just going to finish out the unit testing of motorcycle using this test-driven development kind of approach where whenever we can, we're going to put the code into our test class first, and then we're going to put the code into our production class. And the fact is, you've seen our trick is that sometimes you can put the code into the test class and then Eclipse will say, well, I don't see the code that you're trying to call in the production class. And you go, oh, could you create that for me? And it creates the shell of the code in the production class. And then you don't have to code that shell yourself. You can just go in and put some guts inside of it. So I'm going to pause here and I'll be back in a couple of minutes and we're going to finish out the testing of motorcycle using a test-driven development approach. Hi, I'm back. So if you haven't taken a break, I just had a break. So I just went down and got a tall, cool drink and got all the constructor stuff out of my head. And I'd recommend it for you. So you may want to pause here. And now we'll unpause and we'll get started again. So, how far are we? Well, we've tested each of the constructors. Okay, let's look at that. So we've tested a no argument constructor, a fully overloaded constructor, and a no VIN overloaded constructor. Okay, that looks like what we needed. Okay. What do you have to test in a class? Well, classes really exhibit their behavior and expose their data via calls to methods and or calls to the constructors. Okay? And so you're going to have at least one test case per method or per constructor. And as we're going to see when we get down to equals, for instance, you may want to have more test cases than one for something like equals. Okay, so if you don't have a test for every constructor, if you don't have a test for every method, with the exception of the getters and the setters, then I think you're short. Okay? All right. What are we going to do? So we've tested the constructors. Let's test the toString. Well, we don't have a toString. Well, this is test-driven development. So let's test the toString. So I'm going to type in the test. Okay. So remember, it's public void test toString. No arguments. All right. And also remember, we want to make sure that we already have it wired in, so we want it to fail. Okay, so save, run the test, kaboom, just what we wanted. Okay, and we're going to cheat on this two string just like we cheated on the last one. Okay, um, because I, I think that testing of the two string typically is a good thing to have, because if you go and you add functionality to the class, so the two string representation of the class should change, and you forget to change your test, well, maybe you forgot to regenerate your two string. Okay, so you should remember to regenerate your two string, and you should remember to um, uh, redo your test. So what I'm going to do is I'm going to take our test code that we were using for our fully overloaded constructor. I kind of like that one. Okay, so let's take that, copy it, because that's going to populate all my fields. I'm going to want to see all my fields populated in this test. Okay, and I'm going to need a string to compare this to. So right before I do this test, I'm going to say string expected equals, again, I'm going to cheat and say it's empty in the beginning, right? And then I'm going to say string actual equals M1 two string. Okay, that looks good to me. And then let's do an assert equals. Assert equals expected, comma, actual. And as you very well know, this is going to fail because we haven't told it what it's really going to look like. We're comparing it to the empty string. That's okay. It's a part of our cheating methodology. Okay, so let's see. It expected the empty string but was, and let's just looking at that. Net lodging students transportation motorcycle. Oh, this is interesting. We're seeing that the whole, this is really interesting because I forgot we're a step behind where I thought we were. When you don't have a two string in your class, no explicit two string, your class inherits from a class that's a superclass of all classes in Java, what I refer to as the mother of all classes, a class called object that's in java.lang. Okay? And so what happens is, what we've done is we've called the toString in the object class, and we get a string, but it's not very helpful. It gives us the full name of our class, including its package name. And this thing at the end, I think, is the address where this particular instance of the class is. Oops. Oh. Well, we don't have a proper toString. Let's go fix that. Okay, so we failed the test. Let's go back to motorcycle after the getters and the setters. Okay, and let's generate a toString. Okay, so source, generate toString. We're saying that all of the fields are fields that we're interested in. That's just what we want. We want it after set vehicle ID number. That looks about right. Okay, so set vehicle ID number, and here we can tell that we have overridden the toString from the object class because we have this annotation that says override. Okay, and override is a really nice annotation. It says I'm intending to override a method that is already existing in a superclass, and if I happen to spell it wrong, then I want you to wake me up. So if we had spelled toString the wrong way, it would have said, oh, toSting, there's no toSting in any superclass that you're overriding. So this is our generated toString. Again, if I were to write it by hand, I would not use the name of the instance variables directly. I would have called the getters. I don't want to muck around with generated code, so I'll leave it there. All right, so let's give this a save. Let's go back to MotorcycleTest, and now let's run our test again. And we failed again, but now let's look. If we come down to this error message and double click on it, we'll see on the left we were expecting the empty string, and what we got was motorcycle. And let's just look at what the contents are. Okay, Indian, respect, 1965, red, engine displacement 700, vehicle ID number X 1 2 3 4 5 6 7. Yep, that's what we had. So what I'm just going to do is I'm going to right click and copy this, and I'm going to paste that correct answer into the code. I'm going to save it and run the test again and get a pass. Okay, now this only makes sense if I took time to inspect that result and say, yeah, that is right. I've inspected it and it's right. Don't just automatically copy it without inspecting it. It could be wrong. Okay, so now we've tested the toString. Let's test equals and hash code. Okay, now we're going to learn some equals. So we don't have equals in hash code here. And typically, as you recall, we don't test hash code explicitly. Okay, we usually figured if the generated equals works, the generated hash code's okay. But let's go back to MotorcycleTest and let's create a test for equals. Okay, so I think we're going to do okay if let's copy the one before. Okay, we're going to do this one by cloning. Okay. And let's test equals with the vehicle identification number different. If you remember, the vehicle identification number is not supposed to be significant when we're comparing these vehicles. All the other attributes, the other fields count, but not the VIN. Okay? Okay, so let's see. We've constructed one that looks like this. I don't think we need this expected string. So let's just get rid of that. Okay. And let's just get rid of all that. Okay? So we construct one like that. Let's construct a second one that is only different in terms of the vehicle identification number. So I'm going to copy that. I'm going to paste it. Okay. Now we can't use the same variable name, so call it M2. Okay, and we can't use the same vehicle identification number. So let's just type in a literal string. So let's call it Y987654. Okay. And again, I've got my things off. All right. So we are going to expect the equals test to be, oh, I'm sorry. We're testing the wrong thing. Okay. We want to test if these things are equal. So test equals positive case. I'll remember what's going on here sooner or later. Okay. And then we're not going to do motorcycle2 equal to that. We are going to make these things completely equal. Okay? And in fact, let's call it test equals, let's call it all fields equal. Okay? We want to do that. So we do have all fields equal, right? We want to compare M1 and M2. Okay. And what we want to do is let's explicitly compare them with dot equals. I know that's what JUnit should do, but let's convince ourselves of that. So let's declare a Boolean the test equals M1 dot equals M2. Okay. And let's say assert true the test. Okay, we've done that in a kind of indirect way. So let's expect that to be true. Is that going to be true? Think about it. Not true. Why not true? Well, because we have yet to code, because we're doing test-driven development, we've yet to code the equals. We need to generate the equals and the hash code in motorcycle. So what gets called? Well, there is a dot equals that can be called on any class, just like the toString. The version that you get is inherited from this mother of all objects, java.line.object. And oddly enough, it does an equal test. So we know the equal test is not going to be true. They're not the same object. We just created two different objects. Okay. So in this case, we're not going to have to force a failure. So let's come over to motorcycle and let's generate the code that we need. So let's generate a hash code in equals source generate hash code in equals. Okay. The only thing we need to do is we need to remember vehicle identification number. We don't care about. Okay. Okay, so now we should have a hash code in equals. So there's equals and hash code. They're right there. So let's save that. And then let's go back to motorcycle test. And when we run this, we should get a proper equals comparison. And we do. Okay. So here's what I'm going to do. I'm just going to do it like this. We're going to say assert true M1 equals M2. Okay, and then we're going to assert false that they're equal. Assert false M1 equal M2, because we want to assert that they're not the same object. And how about that? It passes. So what I'm going to do next, I'm only going to demonstrate the first one, and then I'm going to put you on pause, and I'm going to go quite a bit further. Okay. Well, let's see. That's not what I'm going to do next. But sooner or later, I have to show that if I have a different make, that I catch that as not equal, and if I have a different model, I can catch that. If I have a different year, I can catch that. But that's going to take a while, so I don't want you to watch every one of them. But let's first make sure that if we have two different vehicle ID numbers, that they're not considered to be different. Okay, they're considered the same. So let's copy. Let's clone this one. Okay. Sometimes this is hard to think of this. So all fields equal except VIN. Okay. And what we're going to do here is the second VIN. This is the one that we're going to turn into Y987654. Okay, so this should still be true. M1 equals M2 should still be true because we shouldn't be considering the VIN. So let's see what we've got. It did pass. Now, I just want to remind you that we haven't proved that we're running this test yet. So just to be safe, I'm going to force a fail into it and convince myself that I'm really running that test. And I am. Okay, so that's passed. Okay, so we have that. So those are two big tests. Now, I want to show if it's a different make, I catch it a different model, etc. So let's do the make. Okay, and then I'll do the rest of them with you guys on pause. Okay, so here's what I'm going to do. I'm going to copy this. Okay, and all fields equal except make. Okay, so let's have the vehicle identification number. Let's put that back. All right, and let's have the make be who else makes bikes? Harley Davidson. Okay. All right. And what are we expecting? We expect them to be equal? No, we're not. But let's force a failure here. So we've got the wrong thing here. We're saying that they are equal and they're not. So let's see if we can force a failure. Yep, we forced a failure. And then let's come back here and say, oh, you know what? They're not equal because they have a different make. So assert false that. And let's run this. And that passes. So I would follow this pattern for model, for expected year, for model, for year, for color, for engine displacement. We've already taken care of vehicle ID number. So I'm going to put you on pause and get that all done. So why don't you rest up here a second? Hi, I'm back. So while you were resting, I have been putting in the test cases, the remaining ones for equals. Okay, so just refresh your memory. The first one that we tested was all fields equal. Okay. Then we tested all fields equal except the vehicle identification number because that was not supposed to count. We got what we expected. Then the next one that we did after that is all fields equal except for make because that is supposed to count, and that counted. And then I did the same kind of treatment for all fields equal except for model, all fields equal except for year, all fields equal except for color, all fields equal except for engine displacement. Okay? And there's no alternative for having that many test cases. That's how many it takes. Okay, so we've got one more method, a worker method. Okay? In fact, let's test that, and that is to test the determination of the annual fee. And let's look at that. Okay, so test, need the annotation, forgot to capitalize. Okay, public void test determine annual registration fee. I think that's what it's called for car. We want it to have a parallel name. Okay, we have that. All right. So we're going to do a little more of this test-driven development. So let's take a look at this. Okay. So one of the claims that we make about test-driven development is that in writing the tests, we are documenting the requirements of the production code that goes into the class. Okay, so, how's that supposed to work? Well, we have this engine displacement in cc's. Okay, and let's say that if it's 500 or less, it's going to be $50. Okay, if it's 750 or less, it's going to be $100. If it's 1200 or less, it'll be $150. And if it's more than 1200, it'll be $250. Okay, let's really suck it to them if they have a giant engine. Okay, so test determine annual registration fee. Let's say we want to test 500 or less. Okay, so let's say 500 cc. Okay. All right, so let's take a look at this. Let's steal a bunch of code from up here. Okay. So 500 cc, let's say 500 cc. That's looking good. And we do that. So we construct it. All right. So we're expecting, if it's 500 or less, we're expecting it to be $50. Okay. So let's say double expected fee equals $50. All right. And then we can say double actual fee equals M1 dot determine annual registration fee. No arguments. Okay, now let's go a little farther. I know that's not compiling yet. No idea how I did that, but it's certainly not something I want to copy. Okay, so and then we want to say assert equals. Now we're comparing two doubles, okay? And you may remember the problem with doubles is rounding error. And you'll also remember that the assert equals method is overloaded. So there's a method that compares two ints. There's a method that compares two objects of any kind, I think. And then there's a method that compares two doubles, and it takes an additional argument, okay? And I'll explain why in just a second. So we're going to say we have the expected fee. We want to compare that to the actual fee, okay? And then we want to say how different can they be, okay? Because there's usually rounding error between these numbers. So here's what I usually do. I pick a number that's half what I consider to be the significant digit. So if the penny is a significant digit, I make it has to be different by at least 0.5 pennies. So I say 0.005. That is the delta. That's the difference that I consider significant. Okay, it's got to be less different than that, or I'm going to consider it to be an error. Okay. All right, looks good. Now I can't run this because I don't have any code to call, because I'm doing this silly cockamamie test-driven development. Well, I could just say that I want them to create it. Let's say I want them to create it. Well, look at this. It's gone over here, and it has created a method for me. It hasn't put any real work in it, okay? It's returning a 0. That's okay. All right. All right, so in a real method, how do we test it? Well, first we generate the shell, and let me tell you that there's a mantra that these test-driven development people have of the order in which you should test a method like this. And they say this. They said red, green, make the code clean. Okay, so what's red? Force a fail. Okay, why do they want us to force a fail? The same reason we've been forcing a fail all the way through. Okay, we want to make sure that our test is really wired in. Our test case is wired in. It's getting run. We want to make sure it can fail. Okay, green. We want to see that we get the right behavior if we pass back what we think is the right answer. So what we do is we just simply pass back the right answer. That's kind of goofy. And then make the code clean is we actually refactor the code to do an acceptable job of calculating the answer. Okay, let's look. So let's run this test. If we're expecting 50 and it's passing at 0, that's going to force an error. So let's run that. Red, There you go. Now, here's the part that generally makes people a little crazy. Okay? We're expecting a double of 50.00. Let's go in and just phony it up. Now, I usually get groans when I got students in front of me, but 50.00, that's going to be fine. Okay? So let's go back and run that test. Oh, and guess what? It passed. Oh, it passed because we cheated. But we've proven something. We've proven if we get back the answer that we think is the right one, that we recognize it as the right one. That's an achievement in its own right. Okay, we haven't proven that we know how to code it yet, though. So let's do this. Let's say uh, we want to say, okay, let's have some really big default. So double answer equals $250. Okay. And then let's say return answer. And then in between, the only condition that we know about so far from our test code where we're recording the requirements is if it's 50 or less, 500 or less, we want it to be $50. So let's say if get engine, what's that? Get engine displacement thingamarabi, engine displacement in cc's, okay, less than or equal to 500.00. No, 500 because it's an int. It's a whole number, less than or equal to 500. Then we want to say answer equals $50. Okay? So the highest amount that we want to charge overall is $250. Okay? I happen to know that because I just dreamed it up. Okay? And the only thing that we know so far about the requirements is if the displacement is 500 or less, that the proper answer is 50. So we're going to say here, we're going to default it to 250, and if it comes through with the displacement being 500 or less, then we're going to turn it back to 50. Okay, let's see if we get what we're expecting here. It passes. Okay. So what was the next one? I think we said if it was 750 or less, or greater than 500, but more, less than or equal to 750, we wanted it to be $75. So now we write a test for that. Okay, so let's copy this test. So, hey, guess what? We're writing the test code first. And to an extent, we are documenting the requirements at the same time. So let's say 750. That's the highest that it can be there. Let's make this one equal to 750. Okay. Let's expect it to come back at $75. Okay. Now we haven't changed the code, so is it going to come back at $75? No, I think it's going to come back at $250. Let's give it a run. Kaboom, expected 75, but was 250. Oh, that's ugly. Well, what's good here is we forced a fail. So remember, red, green, make the code clean. So We have our red. Now our test is fine. We have to make it pass. Okay? So the next thing that I'm going to do, it's just as easy to put in the real code that will give us the real answer um, than to force a correct answer. So what I'm going to do here is I'm going to say if engine is placed in cc's less than or equal to 500, answer is 50. Then I'm going to say else if, and I'm going to use the same test, but I'm going to make it 750. Else if this less than or equal to 750, I'm going to say that answer should be set to $75. Okay? How's that look? 75 comma 00, nope, 75.00, that does work. And semicolon at the end. Okay, so that should take care of that case. So save that. Go back to the test. The test is already there to work. So let's try that test case. Passes. Okay. And then the only other one, let's just say, take a little of the detail out of the problem, the way I was saying. Let's say if it's 1200 or greater, okay, then it's equal to 250. But if it's if it's more than 750 but less than 1200, it's going to be 150. Okay, so let's do a case like that. Again, we're going to take this case and remember how not only is this a test case, but it's also a way to document the requirements. So the first thing we're going to need is we're going to need one that's 1999. No, sorry, 1199, right? We're going to want one that's 1199 cc's, less than 1200. Okay, it's 1199, so it's more than 750 but less than 1200. Okay, and we're going to say that those should be 150. Okay, all right, so there's our requirement and test. All right, let's run it. See, we don't have that code, so if we write the test code first, it's pretty easy to get an initial failure. Okay, so initial failure, no problem, we got that. And let's go over here. Okay, and I want to remind you that our little mantra, that red, green, make the code clean, when we turned the code green the last time, that's pretty clean code. This is an if. This is a repetitive if-else. That's really basic clean code. I don't see a way to improve upon that. I mean, there are ways to express it different ways, but this is a completely acceptable way. So it was both green and clean. And let's try another else if. Okay, so let's say else if. And instead of less than or equal to 750, let's say less than 1200, because that's the way we've expressed it, less than 1200. Then let's see what we want to give it. Answer equals 150. Okay. So that looks good. Okay, and then let's give it a run. Oh, sorry. You have to run the test, not that one. Run the test. That's it. Okay, and now we need one that's 1200, and we should expect it to be $250 because anything 1200 or greater is $250. So let's go in here. Okay, and let's create a 1200cc bike. 1200cc, make it 1200 cc's. 1200 cc's, and let's expect it to be $250. All right, so let's save it and let's run it. Oh, and it ran. Okay, so we didn't force an error. Now, it's not so much of a problem because we've already proven that this test, no, we haven't proven that this test case actually works. We copied this. Who knows if we copied it right? If we, for instance, left this off, we'd be getting the same result. Watch. Runs just fine. So, got to remember to come back. We need to fail it first. Force a failure to make sure it's wired. Does it fail? Nope, doesn't fail because it doesn't have that test annotation. I also want to show you that if you don't capitalize the T in test, okay, well, you're going to get a compile error, I guess. So that's not going to do it. You need a capital T for a test. So you wouldn't have gotten it done because of the compile error. But you need the capital T as well. So let's run this. That does fail. Now we can pull our force fail out. And we run this. And we pass. So let's go over and look at the code. Is it clean enough? I think it is. I mean, I could get an extra blank line out of it. And there are some people who would not like that blank line there, so I'll take that out. All right, but that's it. Determine annual registration fee is here. It's coded. And let's go over to MotorcycleTest and let's run it. And it runs green. Okay, so now here's a case where we have gone through our entire recipe for a custom class. We've done it a little different. We built the test code before we built the production code, except for the very beginning. Okay? Except for the part where we create the shell of the class and we put in instance variables and we put in the getters and the setters. Those are all things that don't explicitly get tests. Okay, they're implicitly tested starting with the constructors. So then we went back and we created a test for a constructor, and we didn't have that constructor yet. So we went and we did that, and we created the test before we created the code. People feel that this has a couple of advantages. Advantage one, if you create the test code before the production code, you typically can get Eclipse to generate the shell of the production code because it can tell from your test code what the signature of the method that you're calling is. So it knows how to set that up. That's a lot less coding for you. Two, it's a good way to force you the first time you run the test to fail. Okay, because you don't have any code in it, so you can force it to fail pretty easily. That's going to prove that your test case is really hooked up and running. Three, it's a good way to document your requirements. how do you know what the requirements are for this class? Read through the test code. Okay? And fourth, this is something that we've not completely demonstrated, but you're going to have to imagine it. Because we never went over into the code and we never said, gee, I'm wondering what I ought to do for determine annual registration fee. I wonder how that's going to be figured out. Maybe I'm going to do this. Instead of that, all that gee whiz thinking is completely eliminated because by the time we got here, we knew what the requirement was. We knew what the test was and we wanted to pass that test. That sort of elimination of gee whiz thinking and some of the extra features that come along with it is supposed to give you really lean and mean code. So before I let you go, I want to do one more thing. We finally have a package with more than one test class in it, right? So I just want to show, we go down to our test source code folder. We come down into our package, net.logent.students.transportation. We can run the car test by highlighting it, right click, JUnit test. That runs car tests. Okay. We can run motorcycle test by highlighting that, run as JUnit test. Okay. We can do them both. We can do all the tests in this package by highlighting the name of the package, right click, run as JUnit test. And then we can go and we can take all of the tests in our package because they are all in this test source folder. We can highlight that test source folder and we can right click and say run as JUnit test. Okay, now you can do this even if there are 1,000 classes and test classes in your project. And so we just ran, I think, 3 or 4 tests almost instantaneously. We could run 20, 30 tests almost instantaneously. 100 tests, there'd be a little bit of a delay. 1,000 tests, well, we might wait a minute or so. But you'd be surprised how fast these things can run. So this is such a powerful feature. And when you team it up with this test-driven development, which is admittedly a little odd when you first see it, you can really get some great power. So, leaving you to think about that and leaving you to think about your parallel assignment that you're going to be doing, I'm going to say bye until next time. Bye-bye.